You're welcome once again to Reservation Mathematics Institute. This is a platform where we transform the abstract nature of mathematics into concrete concepts. What do I mean by concrete concepts? That simply means that we are using what we have in our environment to analyze the abstract nature of mathematics, since that mathematics has been the problem of inequality. So in our video, the last video, we started on linear algebra, and in that video we made mention of the matrix, where we said the matrix is a rectangular or square arrangement of elements in a regular pattern. But in our video today, we'll be looking into the analysis of the components of a matrix. What are the components of the matrix? That means the keywords that hold the topic matrix. Here we have a rectangle, we have square, we have elements, all must be arranged in a regular pattern. We'll be looking into the components of a matrix. We said is either a rectangular or a square. Now, this is the first thing we're looking into. What do we understand by a rectangle? A rectangle has a length longer than the breadth. This is the length, this is the breadth. That is what a rectangle is all about. And what we understand by a square? A square has a size to be equal. The length is the same thing as the breadth, which is the same thing as the breadth. The third thing, which is the component, is the elements. Anything that has to do with an object or anything on earth is an element. A car is an element, a board is an element, a person is an element, a house is an element, a chair is an element. Those are the key words we are using that will be used extensively in the study of matrix. And let me go back to the regular pattern. This regular pattern has its basis from the rectangle and the square. That means we are only laying emphasis on patterns that are arranged only in rectangle or square. Any other arrangement every other arrangement lies everywhere. But in the study of a matrix, when we are talking about the two-dimensional space, as we have said, the rectangle and the square, as the only platform that exists when treating a matrix. So, what exactly can we say about this matrix? What exactly can we bring together to object this to a matrix? How does the component factor come together to become a matrix? So let's get that, and let's look into the rectangle. This is a rectangle, we have said that. Rectangular, or we are using the rectangle arrangement of elements in a regular pattern. And we have said the regular pattern has to do with a rectangular shape or a square shape. But at this point, we are treating the rectangular shape and the elements in the rectangular form. So these are the elements now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can see from here that the elements here form a rectangular shape because the objects, which are the elements, we have 5 of the elements here, 3 are these as it. And there is something we have to know when talking about the arrangement, the regular pattern. It has a confined term used for an arrangement of square and also a rectangle. That gives us the row and column. The row and the column. It is only applicable when we are treating the 2-dimensional and 3-dimensional space. But at this point, we are treating the 2-dimensional space. That tells us that we have the rows and the column. And what do you understand by the row? We have been hearing about this row and column, row, the first row, the second row. Now, this is just the practical aspect of that. This is the theoretical aspect. We are still looking into the concrete aspect of this abstract nature of matrix. Now, at this point, this is the first row. This is the second row. This is the third row. Now, at this point, we have the first column, second column, third column, fourth column, fifth column. For us to understand the depth of the elements, or the number of elements in a matrix in a square, we have to multiply the number of rows by the number of columns. At this point, you have the number of rows to be 1, 2, 3, and the number of columns to be 1, 2, 3, 4, 5. You have 15 elements. We do not need to count one by one. You have the first row, second row, the third row, and the first, second, third, fifth column. Because on the basis that each row and each column has a specific arrangement, as we have said earlier regarding the matrix involving a rectangular shape. And the same thing applies to the square matrix. The square matrix has the elements with the same number of rows and number of columns. You have 2. This is 2. We can see that we have the same number of elements here, the same number of elements in the second row, the same number of elements in the first row, first column, the second column. This is the first row, this is the second row, this is the first column, this is the second column. We have 2 rows and 2 columns, and the number of elements here gives us what? 4 elements. It's either you count one by one, or you multiply the row by the column. That is just the theoretical aspect that guides the matrix. In our next video, we'll be looking at the practical, which is the concrete aspect that deals with the matrix, and we have that everywhere we live, everywhere we go, every corner in every country has practical examples of a matrix. Thank you.